Right, so here's another example. We have some years and we have the concentration of chlorine in our atmosphere. I'm not sure whether that's a good thing or a bad thing, but it's one of the examples from the book. We know that we're not going to put in 1985, 95, etc. We're going to put 0 in for the first year. 1995 would be 10 years from that. 2010 would be 25 years. And then 35 would be another 25 after that, which would be 50. And I put the stuff in the calculator already. I made a mistake, so I'm going to have to fix that. First thing we want to do is go to Stat, Enter, and that gives us our place to put our numbers in. I put in a 15 for 2010, should be a 25. And then we go to Y equals and go up, turn on plot 1, and then do zoom 9, which is zoom stat. And that should give us our scatter plot of the 4 data points that we've got there, and we do see all 4. And it matches with what we see. It went from 2.5, 3.3, 3.9, and then back down to 3.7. So up and then back down. All right. We need to figure out what type of model this is. We would have no way of knowing this ahead of time, but the book for this particular problem in my math lab tells us we're going to use a polynomial here. Is it going to be a linear or a quadratic or a cubic? So let's go through that. We've got stat over to calc, and let's do our linreg. It's giving us an R of 0.76. Okay, so lin is 0.76. Let's go to stat over to calc. Now down to quadreg. We get our regression for a quadratic. Shoot, I forgot about that. We're going to have to compare R squared values. It works the same as R. For lin, quadratic, and cubic. So for quadratic, our R squared is 0.999, 0.9987. You can go back, but I can't rewind, so I'm going to have to go back and do stat, calc, linreg again, and look at R squared. It was only 0.579. Okay, so our lin was really bad. That's a very low R value. 0.999 for our quadratic was pretty good, in fact, extremely good. And if we go down to cubic, we're never going to deal with quartic, which is the next one down. Our R squared is equal to 1, which is bigger than 0.999. So cubic wins. Okay, cubic is the most appropriate fit for this particular data. Now, I'll let you in on a little secret. That's kind of a bunch of BS, because if you take pretty much any 4 points and you do a cubic regression, it's always going to give you an R squared of 1. Just nature of the beast. But that's what you're supposed to do here, is try the different types, see which one has the biggest R squared. That's the one you want to use. So stat over to cubic regression, and then to put it into Y1, right? Look at that. It's a cubic, ax cubed plus bx squared plus cx plus d, where we have to put all of these numbers in for a, b, c, and d. I don't want to type that in. So instead, before we hit enter, we go vars over, and then enter, enter, enter. And it automatically puts all of that ugly crap into Y1 for me, so that I can look at the graph of the curve and see that it does a perfect job of hitting all of those points. Now this is one where my math lab is going to ask you which graph looks most like the one you got. So again, you have to find it, you have to graph it, but you won't have to do anything with it aside from pick it out of a lineup. And then it's going to ask us a couple questions here. So we've got the graph, no problem. What does the graph tell us the chlorine whatever should be in the year 2020? We go to trace, and again, we're on points. We need to up or down to get to our curve, and we can put in 2020 would be 35 years from 1985. So we see that it should be 3.97. or 92. Looks like it's going to turn around and go back up again. No, I'm sorry, 2020 is in here. And then 2050, that's going to be, what? 2050 would be 65 years from 1985. And we can't put 65 in because it's not within our window. So we have to go to Window and say, I need to go out farther than that. I'm going to go out to 70. And that gives me a little room to maneuver over here. Trace up or down, and then we can put in 65. And according to this model, it should have dropped to 3.124 in the year 2050. All right, hope you're getting the hang of this. We'll do one more. We'll do an exponential one, and that'll be it.